Hello everybody, welcome to another Anatomy and Physiology Live. We're going over the skeletal and the muscular system today. How's everyone doing? Welcome in. Hello, hello. Hello everybody, welcome. We're doing some anatomy and physiology today, some skeletal and muscular system. We'll go ahead and get started here in just a moment. How's everyone doing? Happy Sunday. Hope you guys had a great weekend. How's everyone doing? Hello, hello. Welcome in, everybody. Welcome in. We'll get started here in just a second. I have my Anatomy and Physiology 1 final. Hold on one sec. Your comment went away. Any tips? Definitely go over your old exams. Focus on the important stuff, just like, what's the function of every system and whatnot. We're going to be doing some Anatomy and Physiology 1 tomorrow and Anatomy and Physiology 2 on Tuesday. So that would be definitely great to go over with your live, your old exam or luck because of Logter. I would definitely recommend going to your professor then. Hold on one sec, I gotta make sure my phone is charging because my phone is almost dead. 1 second, and we'll get started here in just a moment. I would email your professor and ask if you can take a look at it. Then I would recommend going back through your material and seeing if you can remember if there was anything familiar to you that was on your exams. Because that's most likely your final exam is kind of what you've already covered. It's just kind of review. Alrighty. My phone is charging. We'll go ahead and get started here. I do have some videos on some finals. I'll definitely be posting tomorrow and Tuesday some finals tips and whatnot. But number 1, what is the name of the gap between the neuron and the muscle fiber at the neuromuscular junction? And hello to everybody that just joined. Welcome in. My name is Ollie. I do go live every day covering anatomy and physiology topics. Today we're going over the muscular and skeletal system. She said she's going to use questions from the quizzes and past exams. Yeah, I would definitely recommend, if you are able to get in contact with them, if you're able to look at old exams and just to be able to see, what kind of questions they asked in the past. Doesn't give an exam just to grade. States to stop cheating. They should at least let you go into their office hours and let you take a look at it. I've never had a professor say I'm not allowed to look at my exam. But I would definitely ask to see if you can go in and look while they're with you or anything, supervised. My phone will not charge. Give me a second, guys. I'm so sorry. We are on number 1. If you are just joining us, welcome. There we go. Okay. Number 1, what is the name of the gap between the neuron and the muscle fiber at the neuromuscular junction? The answer is A. It is the synaptic cleft. So the motor end plate is part of the muscle fiber membrane. The synaptic vesicle stores neurotransmitters inside the neuron, and the sarcoplasm is the cytoplasm of the muscle fiber. The synaptic cleft is that tiny space between the axon terminal of the neuron and the motor end plate of the muscle. So if you have your axon terminal and your end plate, it is the area between here. This is where acetylcholine gets released across. Number 2, which neurotransmitter is released at the neuromuscular junction to initiate muscle contraction? I kind of just accidentally answered that one. I'll give you a second to answer. Thank you, Chanel, for the donut. Thank you so much. Is this AMP1? Yes. Passed. AMP2 with B. Thanks, Ollie. Awesome, Chanel. Congratulations. It's awesome. Thanks for the follows, everybody. If you're new here, welcome. My name is Ollie. I do go live every day covering anatomy and physiology topics. Today we're doing the muscular and skeletal system. Tomorrow we'll be doing some Hessian T's AMP1 review and AMP2 review on Tuesday. For now, we're on number 2, which neurotransmitter is released at the neuromuscular junction, to initiate muscle contraction. The answer is acetylcholine. So we have our little diagram up here of, this is our axon terminal. And we have vesicles in here, which when we have our action potential, calcium helps bring these vesicles to the synaptic cleft to reach our muscle fiber. And in these vesicles is acetylcholine, and they bind and release them. And they bind to nicotinic receptors on the muscle fiber motor end plate. Number 3, what structure releases acetylcholine into the synaptic cleft? These questions, I do repost these live streams to YouTube afterwards. I do have some practice tests on my website. This one in particular isn't up, but I do post these to YouTube afterwards. That's awesome. Number 3, what structure releases acetylcholine into the synaptic cleft? We just kind of talked about that. The answer is C, the synaptic vesicle. Like I mentioned here in this diagram, we have vesicles that calcium carries it across, binds it to the end, and it will, through exocytosis, it will release acetylcholine into the synaptic cleft, initiating our muscle contraction. Moving on to number 4, what happens immediately after acetylcholine binds to receptors on the muscle fiber? What happens immediately after acetylcholine binds to receptors on the muscle fiber? I'll give you guys just a moment to answer that one. Hello to everybody that just joined. Welcome, welcome. My name is Ollie. I have a master's degree in molecular medicine. I've been tutoring anatomy and physiology for about 5 years now, and I also go live every day covering anatomy and physiology topics that you guys request. That's awesome. Number 4, the answer is B, sodium channels open. So let's talk about what happens at our... So this is our crappy axon terminal. We have receptors on the muscle cell membrane. And then once acetylcholine gets released across and it binds to the receptor, these gates, they open and sodium rushes into the cell. When this positive action potential is going to travel to the sarcoplasmic reticulum, in which then is going to release calcium and then further along muscle contraction. Number 5, which enzyme breaks down acetylcholine in the synaptic cleft? Excuse me. My throat's a little closey today because of all the pollen. Got an 81 on my Hezi. Thanks, Ollie, for these sessions. Awesome. No problem. Congratulations on your Hezi. Congrats. I'm in cell bio right now, 2 weeks before final. Good luck on your final. You got this. Cell bio is definitely rough, but definitely keep it up. Number 5, acetylcholinesterase is the enzyme that breaks down acetylcholine in the synaptic cleft after a muscle contraction. Number 6, depolarization of the muscle fiber membrane leads to the opening of which type of channel? What days and time? Kind of depends. I have the schedule on my TikTok page. Go ahead and go check it out over there. I haven't made the schedule for this week yet, though, but it is every day. I do go live every day if you're new here. My name is Ollie. I have a master's degree in molecular medicine. The motor end plate is what it would attach to. So the gap between the neuron, it's the gap between the neuron and the muscle fiber is in a synaptic cleft. Number 6, the answer is sodium. C, depolarization of the muscle fiber membrane leads to an opening of which type of channel? The answer is C. So our little crappy action potential here. This depolarization phase is where sodium is open and it rushes in, which helps generate action potential further. The action potential travels into the muscle fiber through which structures? The action potential travels into the muscle fiber through which structures? These are the structures that are, we've had acetylcholine released, and then the action potential travels down. We have the sarcoplasmic reticulum, but what is this structure in particular called? This allows the action potential to travel deeper down into the muscle fiber. Awesome. And to C is the T-tubule. Awesome. Number 8. What is the function of the sarcoplasmic reticulum in muscle contraction? Hello to everybody that just joined. Welcome, welcome. My name is Ollie. I have a master's degree in molecular medicine. I do go live every day covering anatomy and physiology topics that you guys request. I'll be posting my topic schedule for this week later today. But my YouTube, I post the replays of these live streams to YouTube afterwards, every single live stream. Here's my YouTube. It's linked in my bio. And then I also have my notes and study guides for anatomy and physiology available on my website. It's called MedZig. That is also linked in my bio. So both of these are linked in my bio. Number 8, what is the function of the sarcoplasmic reticulum? The answer is B. It releases the calcium ions. So again, following along with this, we are at our T-tubule, where are the sarcoplasmic reticulum. So sodium rushes in, generating the potential. Once it reaches the T-tubule, it travels down to the sarcoplasmic reticulum, so it can release calcium. Number 9, which ion binds to troponin during muscle contraction? Which ion binds to troponin during muscle contraction? Yes, I post these to YouTube as well, Carla. Yes. Yeah, thank you all. Subscribe. Awesome. And if I do miss a question, I apologize. Sometimes I write on my screen and I miss it, so definitely feel free to put your question back in there again if I miss a question. And the answer is C. This is the calcium the calcium, the ion that binds to troponin during muscle contraction, is calcium. And this is the calcium in the last question, the one that got released from the sarcoplasmic reticulum. So, following along in this little story here, we have our sarcoplasmic reticulum, which released calcium. That calcium binds to troponin. And let's follow along with our next question here. When calcium binds to troponin, what happens next? When calcium binds to troponin, what happens next? I'll give you guys just a moment to answer. My test for this stuff is on Tuesday. Yay, good luck on your test, Kaylin. Awesome, I'm glad. This will be on YouTube later today, so you can go back and rewatch if you've missed anything or you can't stay for the whole thing. I do post all these to YouTube afterwards. The answer for number 10 is B. Tropomyosin shifts to expose binding sites on actin. So following along with the story again, the SR released the calcium, it bound to troponin, and what troponin does is troponin moves tropomyosin to expose actin sites, the binding sites on actin, for the myosin heads to attach to pull it towards the center of the sarcomere to initiate the muscle contraction. Alrighty. Number 11, what molecule provides the energy for the myosin head to perform a power stroke? So tropomyosin, so let's see, let's talk here for a sec. Troponin moved tropomyosin from the active site of actin, and now a myosin, the heads have to bind to the active site, and they need energy to do so, what molecule would that be? It would be ATP. Answer choice C. So we need ATP for the myosin head to perform a power stroke once it binds to the active site and pulls towards the center of the sarcomere. All right, hopefully that makes sense. Is this making sense so far? I'm trying to use questions to guide a little bit of a story. ADP is the result after. So ATP, once we use the energy, ADP is released, plus an inorganic phosphate, and it'll circulate freely to gain another phosphate to become ATP again. Yes, this will be posted today, yes. Is this making sense so far in the story here? I'll move on to number 12. Which of the following must occur for a muscle to relax after contraction? Number 12. Which of the following must occur for a muscle to relax after contraction? This is going to be posted on YouTube. My YouTube is my name. It's also linked in my bio. And then my study guides and notes for anatomy and physiology are also linked in my bio. They're on MedZeg. The answer to number 12 is in my bio. They're on MedZeg. The answer to number 12 is C. Number 12 is C. Did my screen cut off? I'm so sorry. Did my screen cut off at all by chance? So sorry. Yes? Okay, where did it leave off? I'm sorry. Stupid Apple notifications telling me I need to update my phone in the middle of a live stream. It has all day to tell me I need to update, but I don't know why. Okay, where did we leave off? So I'm so sorry about that, guys. So let's talk about this. So I'll just restart the explanation. So which of the following must occur for a muscle to relax after contraction? The answer was C. Calcium must be pumped back into the sarcoplasmic reticulum. Calcium must be pumped back into the sarcoplasmic reticulum. So let's think about why does calcium need to be pumped back into the sarcoplasmic reticulum for the muscle to relax? So when we talk about the SR, so the sarcoplasmic reticulum releases the calcium, and that binds to troponin. What does troponin do? Troponin moves tropomyosin out of the way off of the active site so the myosin head can bind to it, and then that pulls it towards the center of the sarcomere. That's what the contraction is. So we have to cover that active site back up so the myosin head can't do that. So how do you do that? You have to release the calcium from the troponin, and once calcium, I guess we'll start from here. So the tropomyosin moves away. Troponin is what moves the tropomyosin, and what caused the troponin to move tropomyosin away from the active site? That was calcium. Does that make sense? Thank you, Andrea, for the rose. Yes, it does. Awesome. Perfect. We also have to move on. That makes sense. Thank you for the following, guys. Thanks for all the likes on the live. The more that you guys do like the live, the more that it'll get out to people, and the more people we can help on their upcoming anatomy and physiology exams and whatnot. Move on to number 13. What is the role of the motor end plate? What is the role of the motor end plate? Give you guys just a moment to answer that. The answer choice is A. Or wait, hold on. I'm sorry, wait, not A. It is B. I meant to say, I was looking at another different answer. It is to generate the action potential on the muscle fiber. So, the motor end plate, so what is released here at the axon terminal? Acetylcholine. The motor end plate is what contains the acetylcholine receptors for it to bind to. Does that make sense? Not exact. So our motor end plates, the Z line. No, not exactly. The motor end plate is more so a part of the muscle fiber's membrane. So so it would be more so part of the sarcolemma. The Z line is part of the sarcomere. The Z lines indicate the boundaries between adjacent sarcomeres. So the motor end plate would be like a communication site with the neuron, and the Z line is more so a structural part of the organization. Sarcolemma is it's essentially the muscle fiber's membrane. All right. All right, moving on to number 14. What term describes a brief contraction of all muscle fibers in a motor unit in response to a single action potential? It's part of the this is the neuromuscular junction, if that's what you were trying to say. The answer is C, it is a twitch. Twitch is basically a single action potential that produces a muscle twitch. Number 15, if acetylcholinesterase is inhibited, what would happen to the neuromuscular junction? If we remember, it is an enzyme that breaks down acetylcholine. So what would happen there if that remained active? I'm sorry, if it had got inhibited. (15) is C. That is correct. The muscle contraction would continue longer than normal. So ACH would not be able to be broken down. So stimulation at that motor end plate would continue. The sarcolemma would keep releasing calcium and stuff like that. So not good. Number 16, what role does ATP play during muscle relaxation? What role does ATP play during muscle relaxation? So we talked about ATP is what gave the energy for the myosin heads to move towards the center of the sarcomere and bind to the actin site. Answer choice is B. It detaches myosin from actin. So you need ATP to attach myosin to actin, and then you need ATP again to detach myosin from actin. Number 17, what causes the release of neurotransmitter from the synaptic vesicles? The answer is A. This is the entry of calcium ions into the axon terminal. So calcium influx triggers vesicle fusion and ACH release. So we talked about earlier at our axon terminal here. As our action potential travels down, we have calcium channels that rush in, and they bind to the vesicles, and they kind of attach them here, so they morph into and release acetylcholine. Number 18, what structure on the muscle fiber contains receptors for acetylcholine? Kind of we're talking about this a little bit earlier with the motor end plate. What is the motor end plate on, per se? What is the motor end plate on? The release of potassium it's called so we generate an action potential. So we generate an action potential with sodium, and then we have to get the action potential back down. So we have a rush of potassium out. This is what's going to be our repolarization. So we have to get our action potential back down to a resting state before we can generate another one. That is the responsibility of potassium. Yes, so the action potential would trigger the release of calcium, yes. Basically, we have the resting potential is at like negative 70 MV. And then there's a graded potential that kind of gets up here. And once it gets to negative 55 millivolts, this is where the sodium channels open. So sodium channels open, it rushes in, and then it gets up to about positive 30 millivolts. That's when calcium rushes in. That's what opens up calcium and also the potassium. So that's when it can start leaving. But the answer choice is B. It's the sarcolemma. What structure on the muscle fiber contains receptors for acetylcholine? The sarcolemma at the motor end plate. Alrighty. Number 19. What event directly triggers the power stroke during muscle contraction? So the power stroke is when we're taking, essentially is what we're, basically the stroke, think of like a rowboat, the stroke towards the middle. The answer is C. It is the binding of myosin to actin. So myosin heads will bind to actin active site, pulls it towards the center of the sarcomere or the M line. And this is our muscle contraction. Alrighty. Number 20. Which protein covers actin binding sites when a muscle is at rest? This is so fun. I'm so glad. Thank you for letting me know. I'm glad this is fun. The 20th answer is B. It is tropomyosin. Remember, we have tropomyosin that covers the actin binding site, or the active site, and it was troponin after it gets bound by calcium that moves it out of the way so that myosin can bind onto it. Alrighty. Hopefully that made sense, everybody. I am going to take just a little bit of a break. I'm going to fix my computer real quick. And I just have to go to the bathroom. I will be back. We're going to do the skeletal system here in just a moment. I'll be back in question 19 was the binding of myosin to actin. I'll be back in like 5 or 10 minutes. I just have to go to the bathroom real quick, just taking a little break. This is going to be uploaded to YouTube. My YouTube is my name, Ollie Herzig. It's also linked in my bio. And then my notes and study guides for A&P are also they're on MedZeg. These are both in my TikTok bio. I will be back. I said that you forget listen once you get into clinical. Again, this will be on YouTube afterwards if you want access to it. I will be right back. I will be back in like 5 or 10 minutes, and we'll go over the skeletal system. Thanks for watching, everybody. We will be right back. But thanks for all the follows, everybody. Thanks for joining. Excited to have you guys here. You guys are awesome. I love you guys. You guys are so fun. I did these live streams with. I will just be right back.